So continuing on with our trig functions, we're going to take a look at some inverse trig functions. So basically what happens when I have a side ratio and I'm trying to figure out the angle. One thing you want to keep in mind is as we are looking at this graph, the first graph, sine of x, while it passes the vertical line test, so sine is a function, it will fail your horizontal line test, which will mean your inverse is a function. But we know the inverse properties, they're pretty important. So what we need to do is take a look at our graph, and we need to do a restricted domain. So if we restrict the domain of our original sine graph, and we restrict it from this interval negative pi over 2 to pi over 2. So that's approximately here. So there's your negative pi over 2, positive pi over 2. What happens when I'm looking at this section now I can see, yes, it passes both your vertical and, more importantly, your horizontal line test, meaning that section of the graph would be the inverse, or could have an inverse, I should say, that would be a function. So when we're looking at the inverse function, we are only looking at our sine graph ranging from negative pi over 2 to positive pi over 2. And as I look at the inverse function over here, I can see up on top, this would be about a value of positive pi over 2. And on the bottom, here's my negative pi over 2. Keeping in mind when you're doing inverses, your domain and range switch. So the range of our original is now the domain of our inverse and vice versa. So I can see the range of our original went from negative 1 to positive 1. So I'm looking at our domain of our inverse, noticing that our domain of our inverse is going between negative 1 and positive 1. Okay, so as we're going through inverses, probably the most important thing you want to keep saying to yourself is all of these inverse functions, we're looking for the angle. So our inverse sine can be thought of as the angle between negative pi over 2 and pi over 2, whose sine ratio is x. And I have to say this to myself a bunch when we're solving this. So I'm looking for the angle whose sine ratio is what's given to us. Okay. So thinking about this now, knowing that we have our domain restricted, knowing that it's going to be between negative pi over 2 and positive pi over 2, this means our answers are only going to be found in either quadrant 1 or in quadrant 4, but keep in mind to get to quadrant 4, we're going backwards. So anything in quadrant 4 is going to be a negative value. We're going to have a negative angle associated with it. All right, so we're going to try a couple of these. So we're going to find the value of the inverse sine of negative 1/2. So I'm looking for the angle that would give me a sine ratio of negative 1/2. So when I'm graphing this out, knowing it can either be in quadrant 1 or 4, I want to keep in mind that all students take calculus. So I have a negative sine ratio, which means it has to be graphed in quadrant 4. I know sine is opposite over hypotenuse, which means my reference angle is 30. So now I have to think, if I can either be in quadrant 1 or 4, the only way I can really get there is either by going up or by going down, not going all the way around. That corresponds back to this graph, thinking I'm either going quadrant 1 or I'm going back quadrant 4. I'm not going to be over here in this quadrant. That's not part of my restricted domain. Meaning I need to have, if I'm finding, for instance, this angle, this would give me a negative 30 or a negative pi over 6. Okay, looking at letter B. So again, I'm looking for the angle whose sine ratio would give me positive square root of 3 over 2. So sine is positive in our first quadrant, because again, your options are either 1 or 4. It's positive in your first quadrant. We have opposite over hypotenuse. So the other side is 1. That makes this an angle of 60. So in radians, it would be a positive pi over 3. Looking at letter C. So I need the angle whose sine ratio is negative pi over 2. Now when we think about this, that's saying that the opposite side is pi and the hypotenuse is 2. That can't happen. There's no way that that can happen. This doesn't exist. And the reason is because I know my opposite side cannot be greater than the hypotenuse. So there's no answer on this. Okay, we have 2 more. So now I'm looking at a composite function here. And as you see, we have the inverse sine of sine. So you would naturally think, okay, they undo each other, they cancel out, my answer is going to be pi over 5, which in this first case it is. And the reason it is because pi over 5 is in your first quadrant. It's in that restricted domain. So I can say that this is in between our value of negative pi over 2 and pi over 2. So I'm good. I can say, yes, my answer is going to be pi over 5. Now, it's different over here with this one. I just can't say they undo each other and I'm done. I'm left with 3 pi over 4 because 3 pi over 4 is in your second quadrant. An inverse sine is not restricted there. So what do? We solve this step at a time. So we work inside out. Orders of operations says simplify inside, get an answer, and then work your way out. So first thing I have to do is think 3 pi over 4 is 45-degree reference angle. It's 135, right? So if it's a 45-degree reference angle, here's my triangle. So now this is plain old sine saying I need the sine of 135 degrees, sine being opposite over hypotenuse. That would solve and tell me that that's 1 over the square root of 2. So now I need to solve the inverse sine of 1 over square root of 2. So keep in mind, I'm now looking for the angle that would give me the sine ratio of 1 over the square root of 2, and my options are only first or fourth quadrant. It has to be in the first quadrant because that's what my positive angle is going to be, or my positive side ratio. So I have opposite hypotenuse, and that's going to leave me with 45 or pi over 4. So moving on, we're going to take a look at cosine. Now cosine, very similar idea. However, our restrictions are going to be slightly different. So same train of thought as far as I have a function that will fail my horizontal line test, but the inverse has a lot of really important information that we'd want to take a look at. So if we restrict it, and this time we're restricting from 0 to pi, notice in that section, that's going to now pass our horizontal line test. Okay, and again, same idea, domain and range flip-flop when you do the inverse. So if our domain is from 0 to pi on the original, that means the inverse should have a range from 0 to pi. And if our range on our original was from -1 to 1, that means our domain is going to go from -1 to 1. So if I'm looking at my graph here, I can see here's about -1, here's about +1, and we can see how they've flip-flopped. Okay, so what that means now when you're solving for inverse cosine, if I'm going between 0 and pi, that means that I am in quadrants 1 and 2 this time. So different restrictions, different locations when we're graphing inverse cosine. And again, we want to think of it as the angle between 0 and pi whose cosine is. So I'm looking for that angle. Okay. So quadrant 1 or 2, that's where I can do my cosine to find my inverse. This one I'm looking for the angle that would give me the cosine ratio of 1 over 2. And it's positive. So again, if we go back to all students take calculus, if I have a positive ratio, it has to be in the first quadrant. So cosine being adjacent over hypotenuse, that means that extra side's the square root of 3, which would give me a 60-degree angle or a value of pi over 3. Now I have a negative cosine ratio. So if this is negative, my negative is going to be graphed in quadrant 2. So my cosine ratio being adjacent over hypotenuse, other side is 1. So I have a reference angle of 30. Keep in mind I'm looking for the actual angle. Actual angle is 150. So in radians, that would give me 5 pi over 6. And our last one, I have the inverse cosine. I'm looking for the angle whose cosine ratio is pi over 2. So again, this would be my adjacent side, and this would be my hypotenuse. And again, my adjacent side cannot be greater than the hypotenuse. So when I'm doing something like this, it doesn't exist. I have no answer for this. Okay, and then lastly, we're going to take a look at tangent. Same concept, same idea. The basic graph that we take a look at is going to pass our vertical line test as a function. However, it will fail our horizontal line test. So again, we want to have a restriction. And this one is going to be the same as sine, going between negative pi over 2 and positive pi over 2. Notice how we get that one section of the graph. Okay. But notice our range on this is unrestricted, negative infinity to positive infinity. So when we flip-flop, and when we do our inverse, remember everything flips. So the domain of our regular function that we've now restricted is negative pi over 2 to pi over 2. That's going to be our range. So if I'm looking here, it's about negative pi over 2. If I'm looking up here, I'm looking, that's about pi over 2. Okay. But if I'm taking a look at the domain of that inverse tangent, that's unrestricted. The reason is I'm seeing the range of my regular tangent graph is also unrestricted. Okay, so when we're looking at this again, we want to think of this as the angle that is going to be between negative pi over 2 and pi over 2 whose tangent is. So I'm trying to find the angle. Keeping in mind tangents restrictions are now going to be the same thing as sine, so we are in quadrants 1 and 4, but keeping in mind when you get to quadrant 4, we are going backwards, so we have a negative angle when we take a look at this for our final answer. Okay, so for number 3, so we're going to find the tangent, the inverse tangent, whose side ratio is the square root of 3. Keep in mind that could be like square root of 3 over 1. Okay, tangent being opposite over adjacent. So since it's positive, we know it's got to be in the first quadrant. Opposite side, adjacent side, that leaves my extra side of 2. That's telling me my angle is 60, which is telling me in radian form, pi over 3. So the angle whose tangent ratio is the square root of 3 is pi over 3. Okay, letter B, I'm looking for the angle whose tangent ratio is negative 1 over the square root of 3. So it's negative. So my options for tangent are first quadrant and fourth quadrant. And again, if we do all students take calculus, we know tangent is going to be negative in the fourth quadrant. So tangent being opposite over adjacent. This time I'm looking at that angle of 30 degrees. And keeping in mind when we graph, we want to think backwards, which would get us a negative 30 or a negative pi over 6. And lastly, when we're doing this one, the angle whose tangent ratio is negative 1. Okay, so again, it's negative. Again, it has to be in that fourth quadrant. Tangent being opposite over adjacent, meaning I have opposite and adjacent both being 1 to get that negative 1 value, which leaves my hypotenuse being square root of 2. So that gives me an angle of 45, but again, I'm going negative. I'm in that fourth quadrant, so I have to go backwards. So that would give me a negative pi over 4. Okay. Hope this helped. We'll keep practicing in class. Don't forget, like and subscribe. Have a great day.